So it's my pleasure to open the Future of Haskell discussion with the usual Haskell Prime status report. So I'll point out before we start, this is not going to be the usual doom and gloom. It's become tradition. It's going to be a little bit different. So. So I'll review briefly why we did Haskell Prime, why we started the whole process. We had a committee of 18 people. We started it 3 years ago. And the idea was to produce, with the help of the community, a conservative refinement of Haskell 98. We had plenty of experience, many years of developing and using new extensions, and we understand those extensions fairly well, so it seems sensible to try and consolidate those extensions into a new revision of the language. And to reflect the realities of developing practical applications. So the original Haskell 98 had no common function interface, for example, which is slightly embarrassing, and no provision for concurrency. So we've got this sort of ongoing problem that, when you write serious Haskell code, you have to put about 5 lines of extension claims at the top of your modules. So it's going to help quite a lot with that. And the name, this is not the final name. The name was always indicated as always intended to be a placeholder, and we'll decide later. So in terms of recent progress, what's been going on? Well, in March 2007 to February 2008, there was essentially no progress. Things have ground to almost complete halt. And you can see on the right here, we've got the mailing list traffic on the Haskell Prime mailing list. So this period was essentially silent. And then around March and April 2008, I had a very in Poland, and I spent a lot of time working on Haskell Prime. And the mailing list traffic indicates that. So there's a large spike. And then I went back to Cambridge again, and I started working on GAC 6.8.3, and nothing happened on Haskell Prime, which I'm very sad about. So let's review where we are at the moment. There are about 100 proposals for extensions and modifications to the language. And of those, we've made decisions on about half of them. So we've decided yay or nay, pretty much, on about half of those proposals. That doesn't include specifying exactly what those extensions mean, so there's still a lot more work to do there. And 3 of them we've implemented as changes to the report, so 3 of them are complete. But we've accumulated a large wealth of knowledge about the design of these extensions, about how they interact, many of the design decisions that will affect how those extensions are implemented. And that's all captured on the wiki and the mailing list. But if I have to be honest, I have to admit that we're probably only about 10% there. And this is a slightly sad state of affairs. We had a meeting in the Haskell Prime committee last night, and we talked about this problem. And we have to admit that, well, what we're trying to do is too monolithic in many ways. We're taking the approach that we're not done until we've written the report and the language is perfect. And this is too ambitious a goal. And even if we get this done, what about the next version? So this provision of the language seems to be a lot more complicated to define than the previous revision. Is there any hope that we can do this continuously? So what we really need is some process that's sustainable and ongoing and incremental, and avoids burning out just a few people. So we thought about this, we came up with an idea. So what we're trying to do is to change the process and change it in a way that it's focused around individual proposals. So individual proposals are developed independently by a person or small group of people in the community with help from the committee. And these are developed into addenda to the language. And then we'll have a regular release cycle. This is managed by the committee every 12 months. And every 12 months we'll decide, of the proposals that are currently out there, which ones do we think are ready to go into the language? And the committee will work for a small period of time on taking these proposals, specifying them precisely, and aggregating them into a revision of the language report. So the committee is responsible for choosing which proposals go in, and for shepherding them through the process of defining them precisely. And there's chair and co-chair, and these 2 people are solely responsible for actually But we hope that the burden of doing this isn't too high, because it's mainly just an aggregation of these proposals. So the main important thing is that we get to turn over the chair and the co-chair once a year. They're only committing to doing this for a year, and some of the committee as well. So let's look at the anatomy of the proposal as it goes through the process. So we start off with some discussion on the Haskell private email list. So anybody can propose something. They post a message to the mailing list. It provides some discussion, and at some point we decide that this is a proposal that we really want to take to the next step. We think it has promise, and we think we can define it and take it forward to an addendum. So then it becomes an RFC, request for comments. At this point it's sort of loosely defined, and then people are invited to comment on the proposal and try and refine it further. So the community would be allowed to then comment on it. This is probably hosted on the wiki or some kind of community resource. And then this line here is probably at a fixed time in this 12-month release cycle. And this is when the committee decides which of these active proposals we actually want to try and get into the next revision of the standard. So beyond this line, the committee revises refines or revises the proposal into a full addendum, and eventually ends up in the report. Okay, so why do we think this is going to be a good idea? Well, it's designed to have fewer bottlenecks. Proposals can be worked on independently the whole release cycle, so you haven't got to wait for the current release cycle to be at the right point before you propose something. You can do that anytime you like, and you can work on existing proposals. So that removes some blockages in the process. It's sustainable, and we're not trying to do anything too ambitious during each revision of the language. So we can limit the number of changes to just the amount that we can manage. And if a proposal is embedded, we can always just bump it to the next release. And the process is agile. If research uncovers something new and interesting, or problems with existing designs, then we can respond to that fairly quickly. And often language extensions interact with each other in interesting and complicated ways. And by limiting the number of extensions that we try and put in each revision of the language, we can limit these interactions. So it becomes practical for compilers to track the language. Every year, all they have to do is implement the next handful of extensions. And this is, for good reason, this has been shown in projects, and Linux is a very fine example of exactly this model. So in Linux, patches originate at the contributors, and they move up through a series of filters, and eventually they get integrated into the final product. Something else that John pointed out to me is that we can use Hackage to measure how relevant the language is. So given some of the extensions, X, Y, Z, how much of Hackage could we compile if the language included those extensions? And we can see how that grows as time goes on. So I was asked to put up a straw man list of perhaps if we were to do this, what would we see in Haskell 2009? So this is just some of the extensions I took off the wiki that looked reasonable. If yours isn't on there, then of course you can complain. Is it all totals? So what concerns might people have about this process? Well, perhaps the obvious one is that the language is becoming less stable. There are more revisions happening to the language. It's changing more often. So what if you're writing a textbook and you want to use a fixed version of the language? That's what Haskell 98 is for. It's been very good for it. Well, in many ways, extensions are modular. GXC already has a flag for each extension that it provides, and you can have any subset of the language extensions you like. So it's not too hard for us to support all revisions and to keep on doing so. But perhaps also what we should do is to identify major releases of the language. At points along this cycle where we feel that the language is a coherent whole, we might identify it as a major release and fix that and attempt to try and support that in the compilers for a longer period. Okay, so that's all I have to say. We're